What do you guys think?
Perfect. Really, Sadie? Hey, what's this?
Oh, that's the linear shaft bushing. So these are some extremely complex solutions for a quite simple complication. It's really quite amazing. First, let's review some of the basics. Here we have some spur gears of various types, as well as a variant called a rack and a pinion. Rack and pinion gears are essentially a linear shaped variation of spur gears. The spur rack is a variation of a spur gear with an infinite radius. In other words, it's a long straight spur gear. This spur gear we will be using today is an 1144 steel plain bore, 14.5 degree, 12 pitch, 32, 2.5 pitch diameter with a 625,000th bore. Here we have a compatible rack for the spur gear. This particular rack is made of a particularly common plain carbon 1018 steel. This type is approximately 50,000 and up to 250,000th 1% carbon content with up to 400,000ths of a percent manganese content. We now have a hexagonal shaft made of a mild cold drawn steel with a yield strength of 54,000 psi and a medium hardness of Rockwell Beef 70. This stuff meets ASTM, also known as the American Society for Testing and Materials A29 and A109 specifications. So, a hex shaft having an outer circumference of 565 thousandths and a spur gear bore of 625 thousandths, we engineered an adapter in our SolidWorks and had a resident engineer print it on our 3D printer out of a very crude material known as polylactic acid, or PLA for short. So what does all of this mean? Well, we're now able to take this gear with a round bore and attach it to this hex shaft and maintain concentricity. Yes, concentricity while welding these existing spur gears, which serve no real purpose as gears anymore, onto the face of this gear. By using special tooling clamps, we are able to precisely weld this stuff together with a metal inert gas welding machine, also known as a MIG. This has allowed us to keep the gears perpendicular to the shaft as well as maintain concentricity in order that during use, the spur gear will maintain contact and function properly without slippage while traversing along the rack. So here we have the hexagonal shaft with the bushing pressed into the gear to keep it nice and centered and still. And then on this side, the bushing's not fully pressed in yet, so we're going to show you how we're going to do that. We're going to use this gear as a guide. And then we're going to have one of our engineers press that in. Perfect. Now you can see that the bushing is perfectly inserted into the gear. Alright, so now we're done. So that's what the linear shaft bushing is.
Well, that's what that is. What's this?
That's the robot!
Don't ask her about that. We'll be here all night.
Well, that's why we hired her.
Worst mistake.
Hey!
This is gonna be one long blooper reel.
Take 467.
Don't do that!
And action.
Oh, that's the linear.
Perfect.
Cut.
I'm so sorry, guys.
Linear shaft bearing or bushing, whichever.
Bushing!
Bushing, bearing, same
Something
thing.
ink.
Bushing. Okay.
From the top.
From the top.
Now able to take this gear with a round bore. No, which gear?
That's the gear.
Oh, it is the gear.
Good timing.
Whose phone was that?
No, it's dying. In order that during use, I can't. Can you put a comma in there? It's messing up my reading.
Ah, missed the cue.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. ¡Ey, Macarena! High five! High five! High
It's so entertaining.
Are you measuring
It's
Vincent?
just like armworm.
I got like everything. I don't stop.
Okay, I'm
Still
gonna,
going?
It's been going the whole time.
wait, where's my pillow?
Oh, I was like, whose foot is that? And I was like, oh.
I have had exhibitions of learning. I have had. Well,
Hey, what's
yeah,
that thing?
but not me.
This is Vincent.
You're built
Our
for,
mechanical
long
snowman.
distance, like stamina work. I'm built to go hard and fast and go hard.